Hey there, this is Max Doolin, and this is the Blocks 1 challenge from the 6th year of the Spokane Cyber Cup. This challenge was written by, not me, because I don't do cryptography things. It's written by Max Arnold, who loves cryptography. He's the only person I know that's actually completed CryptoPals, which is pretty cool. So let's get into it. Blocks 1. I've created a leading edge system to encrypt a secret value using an encryption algorithm used by the US government. To connect to this challenge, log in via SSH to URL to this port as the user blocks 1. No password is needed. How fancy. And then you include this file for download. Hint, Python is a great language to manipulate strings and send data to an SSH connection, but you can also do this challenge by hand. Look carefully at how the decryptor tries to prevent you from decrypting the secret. Is there a way around this check? The padding at the end of the decrypted test message needs to be correct. Is there an easier way to force the padding to be valid? So, I think the easiest way to demonstrate and show this is just start working on the challenge. So, the first option is get encrypted secret, and this will be important, so we can copy that for later. Encrypt test value and decrypt test value. So, we could try to decrypt that, and it says it's too long, so let's shorten it. If I recall, the maximum length that we can use is 16, so it's checking to see that. So we can do inc equals this. We can do inc of 0, 16. And of course, this is 16 bytes. This is just 8 bytes because I'm taking each 2 hex values is 1 byte, but just for simplicity, I'm going to do that first. And if I try to decrypt that, it says decrypting the string is prohibited. Try something else. Why is that? It says if message in a void. A void is what information we have. A void is the flag that's encrypted. So the very beginning encrypts the flag. If we ask for that, it will actually give us that. So that's what's being returned. But it doesn't want us to be able to decrypt the flag, of course. So it's trying to check to see if we're providing the flag. If we're providing a subset of the flag, so if that string is in a void, then reject it outright. Cool. So now we know there's a couple of restrictions. One is that we have a size constraint. The other one is we can't use the message. The encryption algorithm being used is DES, and it's using a mode called ECB. Turns out the ECB is the important thing about this. DS is a block cipher, meaning that you give it a piece of text and it will encrypt it in groups. And depending on the mode, you encrypt different amounts of bytes. Cool. So an interesting property of ECB, or electronic code book, is that the individual blocks don't affect each other. Remember, this is a block cipher. So with a block cipher, actually, maybe I can just look this up. Block cipher ECB. Cool. This is my favorite picture of it. Cool. So what this shows us here is, damn, that's the wrong file. Okay. This is the image. All right, pardon me. So in this case, we have our plain text, or the data we want to encrypt. We have the key that is encrypting it, and then we have the ciphertext. The ciphertext is the output. But notice that each group of plain text gets encrypted, and there's nothing that happens further down. In modern block cipher modes, the previous ciphertext actually affects the result of the next one. And because of this, you can actually just swap blocks around. So for instance, if I have block A, block B, and block C, it doesn't matter the order of them. You can just swap them around and it doesn't matter. So we're going to use that property of ECB mode in order to cause some havoc here. So we know we can swap stuff around because at the end of the day, it's just using the same key. So the other thing we can do is, or the other thing we need to bypass is this check. This check is saying message in a void, and it's checking to see if what we're providing is within the encrypted flag data. But if we provide different parts of the flag or we pad in different ways, then we can we can bypass this check. I think the easiest way to do this is to just get the encrypted string of something that's empty. So for instance, now we have this 16 here. We can also you can do that. Whoops. Cool. So that's going to be the empty string. Great. You can see here that we've actually started to see a flag. So you're probably wondering, why can't we just use this and add a couple of extra characters? And the reason you can't do that is because you need the multiple to be correct. And I think that this would probably error if you did something different. For instance, if you provided so BB, CC, DD, EE, FF. Nope. Oh, that's the choice. Whoops. If we do decrypt, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16. And I did it again. Alright, so now I'm trying to pad this out correctly. Actually, these aren't valid hex values, so we'll just wrap round. Cool. So the reason it's an invalid input caused from exception is because there's a padding issue. These encryption algorithms have padding that if you don't provide the entire block or if you don't add a block amount, for instance, like 8 bytes, then you need to have a padding to ensure you're not confusing the padding with the data. And this is how this is done. So I found the easiest way to get around this is to use an empty string. But another solution that's I think would work, I actually haven't tried, but we're going to try, is we could do something like this, where we do like 32 through 48. And because we have all the 8 bytes there going correctly, then nope, it still gets an error. Never mind, that doesn't work. But the point is that we have the correct padding from that empty string. So we know that this here is the encrypted empty string, which has all the padding we need, and then that's the encrypted data. So now we can do 16 and 32 and do this again. Cool, so we can do this over and over again until we have gotten all of the information out of it. So 32, 48, whoops. (16 plus 16). Damn, this is a long string. Come on, Max. Why do you have to make this file or this so long? All right, so I'm just gonna do this last one, but you can see here we have the end of a flag, and if you did this for all of them, you would eventually get it. So I'm now just going backwards. You would know this was invalid because it would either tell you or it would look like a bunch of gibberish. All right, I think this is the last one. Dang. Cool. So you can put all this together, get the flag. the flag ends up looking like, nope. The flag ends up looking like this. It's pretty long, but I think Max makes a good point. Stop using ECB. ECB is bad. But I think it's a pretty fun challenge. I feel like crypto challenges can either be really complex math or just be overall difficult. I think although this is a harder challenge, I think if you understand the basic properties of ECB and the security checks that are in place, you can kind of start to work around how to bypass this. And I think that's pretty fun. So great challenge written by Max. Thanks for writing that. Hope you guys had a good time. See you in the next one.